Hi, Julian from PopcornFX here. In this video we are going to take the dust motes effect we made in the previous videos and see how to add a pre-warm effect to it so that whenever you start your level the particles all instantly appear and you don't have to wait for the player to see the particles coming in over multiple seconds. In this case they live for 10 seconds, so the player would have to wait 10 seconds before seeing the full dust effect. So here if I reset, you'll see it takes a long time to reach the 25,000 particles. And this is basically because I'm spawning at 2,500 particles per second and they are each leaving 10 seconds. So it takes 10 seconds to reach the max count, and then the first particles start dying off and the system auto feeds itself with new particles and dying particles, etc. So when you come into the level, when the player arrives in the level, you might want all the dust to be already here and not have the player having to wait 10 seconds to see all the particles of your effect appearing. So we can very easily do that by using another multiplier node. So I must say that there isn't any built-in pre-warm currently in PopcornFX version 2. This would require running a couple of simulation steps. We can actually do that in the timeline. Here when you click at 10 seconds it will instantly simulate to this point, but this actually takes some time. You don't necessarily see it here, but if you have to do this for lots of effects it actually has to take multiple sub-steps because some effects can't be instantly seeked, especially the ones using turbulence. It will give entirely different results. So there is no built-in feature for that. But we can work around it, and here if I add a new multiplier node that has a duration of 0, so instant spawn, and if I tell it to spawn 25,000 particles, here when I restart the effect it will pulse 25,000 events out of there, and I can basically wire this here, and now when I start I have 25,000 particles. The reason they still appear or take a little while to appear is because I have this fading here, this curve over time node. If I shorten that, now you can see them instantly appearing. But here you can see that it doesn't stay at 25,000 particles, it goes up to 45, perhaps more, and when the 10 seconds mark is reached, the 25,000 first particles all die in the same frame and we instantly go back to 25,000. So here, near 10 seconds, instant go back to 25,000. So this is because when they are initially spawned, they all have that 10-second life. So it's pretty normal that they do that. So we can fix that by, bear with me here, I'll show you afterwards how to not do that. But here we'll just copy paste the entire layer just to validate that it works, and instead of wiring in 10 seconds, I will wire a random node between 0 and 10. And now you can see that they stay roughly around 25,000 particles. I could actually do something more elaborate by using the parent life ratio. I'm not even sure this is going to work. If it's not, I'll just edit it out of the final video to not look stupid. But this in theory should work. So parent life ratio will be 0 for the first particle spawn and 0 for the last one. When in instant mode, perhaps it just won't work. And yeah, it works. Great. So much better than the RAND actually. right? So here we have a way to instantly pre-warm the effect. But it's not ideal because I had to actually copy-paste this entire layer. So this means that whenever I tweak things in this layer, I will also have to tweak the same things in that layer. And that's far from ideal. So there are a couple things we can do here. We can either create a template out of this layer and simply copy paste the template, and the template node will have the same layer inside and we'll be able to tweak that layer. So let's do that. I will Control G and name this dust behavior. Right, so now down there I have my dust behavior layer. I will just change its class type to event just to have the same color as a regular layer. And if I copy paste that here instead, I can now go in there. So this is now the exact same layer as if I open it here, because it's the template node. Quick tip here: when you create template nodes with layers, if you don't want to go to this intermediate view of the actual layer and want to directly, when you double click on your template node, go inside the layer instead of going through here, you can select a layer there and click auto entry point, and this will tell the editor that whenever it opens this node graph, it should also automatically open this layer. So this allows you to chain auto entry points and directly direct the user or whoever opens your template to the actual interesting part. So here now, when I go back and forth, when I double click here, I'm directly taken to the actual layer. So here, instead of 10, I will create an input node. I was typing output, not sure why. Right. So an input node of type link with a default value of 10 is fine. And then when I need to go back to this intermediate layer to export it to the template. So to do that, now that you have the auto entry point, you will need, the only way for you to go back to this intermediate layer to expose this input is to click here. And here you have access to your layer where you can say auto export this value. So now I see it here. So I don't actually want it to be visible as a pin, so I will uncheck the visible by default checkbox here, go back to auto export it, and here, so 10 seconds, that's fine, but this one I want to wire in my custom logic to set the life. So here I will expose that, and I will wire in my parent life ratio times 10. Right. And now when I reset, I have my correct behavior. And I have a single layer for the actual behavior. So this prevents me to have to tweak things twice when I make changes to this layer. So that's the first way to do it. You have another more interesting way to do it, because basically this here will duplicate the simulation context in the simulation runtime. So we call these mediums, particle mediums. They are basically the runtime objects that take care of simulating a layer of particles. So they have the storage of the particles, they have the various simulation objects that are run at runtime. It's these objects that dispatch the simulation tasks, etc. In case of GPU simulation, it's those that contain the compute shaders that are used for the simulation. And the more mediums you have, the more overhead at runtime. And here we're basically having two of these, because even though they are referencing the same layer, this will actually get expanded as two different physical simulation mediums at runtime. Because here we are changing what's inside, so it can't be merged. So let me explain that a bit better, perhaps. Here in this one, we say 10. The life should be 10. So when the graph compiler comes in and compiles that graph, it inlines 10 in there, and it will do a set life of 10. So here, if you look at the instructions, let me switch to shipping so it's a bit more readable. Right, so here if you look at the instruction, you can see self.inverse life equals 0.1. So the life is actually stored as the inverse life, so that's a detail. If I go into that one, even though it's the same layer, it gets compiled differently. So those nodes here are basically injected in there and optimized with the rest of the nodes as if you had created as if you had copy-pasted the layer and inlined those directly yourself, what we did first. And so this actually creates a different simulation. So there can be a small overhead for that, and the most efficient way to do this is to basically have a single layer that takes care of all the simulation logic. So we are at the second way to do this. So the second way to do this would be to use event payloads. So I'm going to go pretty quickly on this because I don't want this video to become too long. So the idea here is that we basically oh, I can ungroup. Right, so that's a new feature. You can right click on a template and pick ungroup, and it will basically copy paste what's inside into your current graph. So that's a pretty nice shortcut to undo a Control G, or to undo a template, to auto inline a template. Right, so here I have this layer. I'm going to delete this and to delete all that as well. And here I want a single physical layer, and somehow to say along this event wire to tell it that here it should use a different way to compute its life when it's triggered by this wire than when it's triggered by this wire. So to do that, we can actually insert an intermediate layer that will add a payload to the event wire to tell this layer, oh, don't use 10 as the life, use what we had before, the parent life ratio times, etc. So here, in this layer, when you open it, you will see that the editor has automatically created what we call a pass-through layer. So the pass-through layer is automatically created when you insert a new layer on an existing event wire. And what it does, it basically does a trigger true at spawn. So this always pulses a new event. So whenever this particle is born, it instantly pulses a new event out. And it takes the parent payload and copies it into the outgoing payload. So everything that the event wire coming in is sending as a payload will get copied to the outgoing event. So this is basically a useless layer, because it does nothing. It just instantly forwards the event, copies all its payloads, so I can delete it, I will have the exact same behavior. And when I'm talking about event payloads, I am talking about this data here, which you can also see by, or which you should be able to see by hovering the event wires. and which for some, oh, I'm in shipping, right. Did I mention that shipping disables some editor features? So shipping here allows you to preview the simulation as it will be in the game engine with all the optimizations enabled, but it will disable some editor features that rely on some optimizations not being applied. So that's why you have this warning here when you are in shipping. So you should usually use the editor mode. And now I should be able to see or not. Okay, so maybe oh, all right. Yeah, those tooltips in the node graph, we need to redo these. For some reason they stay up for a very short time and are hard to read, and sometimes they don't even pop up. So basically here you see the list of all the payloads that are sent. So the payloads are basically data attached to an event. You can see the incoming and outgoing event payloads there. Right, so here we are going to add a new payload. So let's say I add an append payload node. Here it's just telling me that I need to name this payload, so I will name it, let's say, lifespan. And here I will wire the parent life ratio times 10. So the actual lifespan I want. And this tells me, oh, that there is already a lifespan payload. Is there? Oh, yeah. Okay, so the event multiplier already sends a lifespan. I should choose a less common name. Dust life. It's not thug life, it's dust life. Right, so here it tells me that dust life is unused in all its targets, so there is no layer wired in here that is using dust life, so that's basically a useless payload. That's fine, I'm going to use it right now. So I take an event parent node, and here I do an extract payload with dust life. And now if I wire this in here, you will notice that the particles instantly spawn, but then we have no more particles. They all die. That's because when an even payload isn't found, it defaults to 0, and along this wire, for the particles that are supposed to be living with the actual rest of the life of the effect, not at spawn, with these particles I'm not sending a dust life payload, so they basically all spawn and all have a duration of 0. I can take a look here at the pipeline view. So here I can see that I have most of my particles that go through the kill pipe and die instantly, and I'm only left with a single particle, which is this event multiplier here. Whereas when I respawn, I do have the evolve pipe that's busy. So I can do something very simple here. The extract node actually has a found pin, which will be true if the payload is there and false if it's not. So I can just use a simple if node. If it's found, I use the value. Otherwise, let's say it's just 10 seconds. And now I have my behavior as expected, 25,000 particles always. And I do have a warning that tells me that the dust life isn't provided by all the event wires that trigger this layer. So this is fine. I'm using the found pin, so I can just say ignore warning missing, and the warning is gone. And the last thing before we wrap up, you will have noticed that I basically hard-coded here the initial spawn count to be this value here times the age, the max age of my particles, and that here I also hard-coded the max age. So whenever I will want to change this max age, I will have to go edit two different layers, know exactly in which place I need to edit it. And same thing for the spawn count here. If I decide to increase that, I will also have to increase the spawn count in the prewarm node. So I don't really like that. So instead, what I'll do is expose this spawn count here, expose the initial spawn count, and for the initial spawn count I will actually initialize it to be the spawn rate times the age I want. So this starts to look a bit messy, but we'll get there. And here I will expose this as a link, which I will name dust lifespan, that I can see here. I will wire that in, and same thing for that one. I will actually expose that as a link as well, named dust lifespan. Expose it there and wire the lifespan in. So now I have those two values that are wired in all the places that actually use those properties, but it's kind of messy here. So instead what I can do is select those constants and hit Ctrl G to create a new group that I will name dust properties. It's not really the properties of the dust, but it's it's not really the properties of the dust, but it's a node that will allow me to factor various constants and reuse them all over the place. So here I was hitting Ctrl Shift G instead of Ctrl G, and it created an annotation instead of grouping the nodes. So here with Ctrl G, dust properties, I have my new dust properties node down there. And now to tidy this up, I can basically clone the node, and in there is no need for me to expose this in here or here. So I'll actually simply directly copy paste it in there. Dust lifespan. I hit Ctrl U to collapse the unused pins, and I will also place it in here. Right. So now I have a much tidier graph for my prewarm. I kind of like having the wires nice and tidy. So now whenever I want to change those constants, I just need to go inside the dust properties template and edit these. Say I just want them to live for 1 second. So now I'll have much less. I want them to spawn at a rate of 500, and now the prewarm has the correct spawn count, and the full effect afterwards also has the correct spawn count with me just editing it in a single place. And I can actually expose these as attributes, as effect attributes, that will allow me to control this from the game engine. So to expose a value as an attribute, you just right click on it, choose export as attribute. I will name this attribute dust count, dust motes count, and that one will be dust lifespan, or actually just dust count. Right. And now in there, in the effect interface panel, I have those two values that I can then tweak and that I will be able to change from Unreal or Unity or an in-house engine where I bring this effect in. So I can set this up to be a slider, to have a min of 0 and a max of, let's say, 10,000 if we really want to go crazy. And for this one, I will actually set it to 5 by default, also a slider. And so there is one interesting thing to note here, is that when I change the dust count, you will see no change here, and this is because these are used as the inputs, the spawn count inputs of the multiplier node, and by default these are set to be evaluated at spawn time, so they will be only evaluated once when I start the effect. So here, if I set it to 10,000 and hit Ctrl R to reset the effect, here the multiplier nodes will correctly pick up the 10,000 particles per second. But when I dynamically change it, they won't, so I need to select these two and set them to evolve. And now they will properly update as I change the sliders. So there we have it. I hope you liked this video and it wasn't too long. Stay tuned for the next one, where we will see how to create a simple rain effect building upon this dust behavior here. Thanks for watching.